When using the right-hand rule, there are a few important things to keep in mind. First is the charge. If the charge is positive, the right hand can be used. But if the charge is negative, the left hand can be used. Or you can still use your right hand, you just have to change the final direction of the resultant vector. The next thing important to keep in mind is the direction of the two vectors being cross-multiplied. The direction of those vectors are really vital for determining the direction of the resultant vector. But the two applications we have used in class and in homework is associated with the magnetic field and magnetic force. So when calculating for the magnetic field, the velocity vector and the separation vector are being cross-multiplied, while when calculating the magnetic force, the velocity vector and the magnetic field are being cross-multiplied. And it's important to note that the right-hand rule only gives the resultant direction. For me, it's easiest to first draw a schematic of the graph in 3D. So once I've drawn my graph, I place a point in each direction of the cross product vectors, and then I can use my right hand to determine the resultant direction. So for example, let's solve for a magnetic force. Say that there is a positive charge with a velocity vector in the negative z direction and a magnetic field in the negative x direction. So from there, I can say that if I put my hand in the negative z direction and curl my fingers towards the negative x, which is representative of the first and the second, I can see that my thumb is pointed in the positive y direction. And if the charge were to be negative, then all I would have to do is to flip. But since my charge is positive in this case, it would be positive.